Hi, my name is Amit Nandi and I work with Prolim. I lead the simulation portfolio team from Prolim. I take this opportunity to share my experience of working with various electronics manufacturers across the country. By looking at these pictures, I think even you might have experienced these kind of electronic failures in your life, right? These pictures always remind me the cell phone which I bought with my first salary. That cell phone was made up of a metal casing, and whenever I used to keep it for the charging, it used to get heated like anything. The moment it hits the 80% of charging. Sometimes I used to feel the heat during the call also when the call goes for a very longer duration. The statistics says that heat is the major source of any failure of electronic systems, which is contributing almost 50% of the 55% of the overall failure of the electronics systems. I hope this also you might have experienced it with one of your gadgets. It may be cell phones, or it may be your watch, or it may be your personal computer or laptops. The reason for this failure is the strength of the frame, which is not able to withstand the impact load when it gets slipped off from your hand and impacts the floor. This is contributing almost 20% of the overall failure of electronic systems. On the other hand, if you look at the lighting industry, the lighting system also consists of the electronic systems into it, right? So this always reminds us about our long drive to the nearest hill station or nearest fall strip during the monsoon season. The droplets of water or the rain gets accumulated inside the lighting system, and then once you start the vehicle and you start driving during the night, you will switch on the lights, right? Because of the condensation and evaporation, uh, the fogging happens within the uh, lighting system, eventually leading to the electronics failure sometimes. And also it make the electronic systems faulty during the operation as well, and you will not be able to visualize the roads or way properly, which sometimes leads to accidents, right? So the next to it is the dust accumulation uh, of uh, dust accumulation in any electronic systems. So, if you look back, the contribution from the uh, human in terms of the failure of electronics, that is almost uh, 90%. And if you look at the structural failure of any electronic systems, is contributing almost 20% of the overall failures. Then comes the dust accumulation on the PCB or within the electronic systems. So the failure due to this dust accumulation uh, is almost contributing maybe the 6% of the overall electronics failures, which is not that high, and we rarely find such type of failures. So once the design of the electronic systems are done, there'll be uh, there will be a lot of radiations emitting from that electronic systems, right? And that will be interacting with the other electronic systems or the other systems. So there is a board uh, which has set up the regulations on the emission of these radiations from the electronic systems. So the compliance has to be satisfied with respect to the emission coming out from the electronic systems in terms of the radiation. So the finally the noise coming out of any electronic systems. So recently, that is day before yesterday, I faced this problem with respect to my computer, where I was running so many applications, that is web browsers and my uh, Outlook, and then other software applications were also running simultaneously. During that time, I was capturing some session video, something like this, for one of my client. So once I'm done with the recording of that session, when I went back and started checking uh, the recording quality, then I realized that the sound of or the noise coming out of the laptop was much higher than my voice. So that's where the people get annoyed, and then eventually what I did was I shut down the system and then kept it to cool for some time, and then again I switched it on and then started working on it. And again I had to rework on my recording things. So these are the typical failures what we see in our day-to-day usage of gadgets, right? So it may be the cell phones, it may be the computer systems, or it may be the laptop systems, or it may be the camera systems, or it may be any systems. So nowadays, no system is purely a mechanical system, right? So all systems are smart systems. That is nothing but the mechatronic systems. So we have to address all these challenges. Otherwise, these challenges or these problems or these issues will lead to the very expensive engineering mistakes in our products. So let's take some examples related to these mistakes. Before that, I think what we discussed just now, that is 50%, 55% of the failure of electronics is coming from the heat, and 20% of the overall failure of electronic system is from the structural stability, that is maybe the vibration or impact, and then 90% of the failures coming from the humidity, that is nothing but the operational condition or environmental condition, and only the 6% of failure is contributing from the dust accumulation in the electronic systems. So there are some engineering mistakes that have been uh, carried out or that have been done unnoticingly or by mistakenly, right? So but eventually that will cost very huge amount of money to that particular organization. Here I'm going to take two high profile such examples. That one is from the Boeing, uh, uh, that was about the Boeing 787 Dreamliner aircraft. So what happened was there were many international flights flying from one country to another, and then in one of the flight which was going through the Japan, suddenly the pilots, passengers, and the crew members started smelling of the burning thing. So what the pilot did is immediately he took the decision of emergency landing in Japan. So the issue got reported to the Boeing engineering team, and then the engineering team flew to Japan and started investigating what is the cause of that smell. Then, at some point of time, they realized that that was because of the overheating of the batteries, which eventually made it to fail. So that was the smell coming out of that overheating and the failure of the batteries. So this expensive engineering mistake, uh, costed Boeing almost $600 million. The another example of such high profile is Samsung. Samsung had released Galaxy Note 7 maybe in 2015 or 2016. So I think you still experience the you know the failures of the Galaxy Note 7 in airport whenever you start checking in, right? So they always ask, or you will read somewhere that are you carrying the Galaxy Note 7 mobile or what? That is because of the faulty battery, the Galaxy Note 7 exploded, and then you know which was a disaster, we can say. So this expensive engineering mistake costed them almost $5.3 billion. So this is how the costly engineering mistakes will cost the companies a lot in terms of the money, or in terms of the recalls and repair expenses. And later, Samsung almost replaced 97% of all Galaxy Note 7 with a new one, or with the approach of money back or something like that. So this eventually lead the organization to bear the recall and repair expenses, which are very high, and also they will lose the market opportunities, and eventually leading to the damage to the brand. Now, how ProLim can help you in building the best performing electronic systems. So, with the help of SimCenter simulation portfolio from Siemens, we can help you to validate your designs with respect to the thermal performance, that is, whether the temperature which is getting generated in the electronic system is very high, or is still under a certain limit or what. That you can validate well in advance during the design phase, and based on that you can work on the cooling uh, systems as well, whether it is maybe forced convection or free convection. Then comes the impact or load carrying capacity. So with the help of SimCenter simulation solution, you can predict how much load it can withstand without any damage to the electronic system well in advance in the design phase itself. And then you can model the dust, or you can model the humidity, or you can model the extreme temperature uh, condition, or extreme cool temperature condition in the virtual environment with the help of SimCenter simulation portfolio, and you can predict what happens in terms of the performance of the electronic systems. And then comes the acoustics part, the noise getting generated because of the fan. Once you fix up the thermal performance or thermal issues, then I think that almost solves 50 to 60% of the noise problem. So SimCenter acoustic solution will help you to find the source of the noise, and then you can also see, or you can also check how the noise is getting transferred through the casings of the electronic systems, whether it is through casing or whether it is through air. So based on that, you can work on the modifications of the design, and then finally you can achieve certain dB of noise level. And then comes the EMI EMC part of electronic systems. So with the help of SimCenter solutions, you can perform electromagnetic simulation for the compliance issues. This is how SimCenter simulation portfolio will help you to validate the performance of the electronic systems, starting from the concept stage till the validation stage. So this is how Prolim can help you in increasing the performance of any electronic systems, and you can always reach out to us for more details on this. Thank you for watching, and feel free to reach out to me for any kind of queries, or if you want to know more on this topic, you can call me up on 916-450-4590, or you can drop a mail to amit.nandi@program.com. Thanks once again. Have a